video is for the first project for trigonometry. So some of you have taken the Math 111 or Math 116 courses that I taught, and in those cases you're familiar with how I want you to do the project. For those of you who haven't had my class before, this opening sentence at the very top of the page, it says, be sure to read tips for completing the projects for instructions on how your project should be done. Please do that, okay? Please make sure to read through that, because what I'm looking for is I'm looking for a report on your solution to these problems. Written on a word processor, in paragraph form, using complete sentences with an explanation of your solution. Okay? All right, so let's look at the problems. In problem one, we've got this is a classic problem of carrying something around a corner where we've got a hallway here where this is 6 feet, and then a hallway down here with a width of 9 feet. And the idea here is, as you're carrying it around the corner, it's going to cut this diagonal in a variety of different ways, okay? And we're interested, let me draw another look at it over here so that we just get a single line, just like it is on the assignment. And there's our angle theta. It's the same as that angle right there. Okay? All right. So let's see here. So the idea here is that if you've got this pipe and you're trying to carry it around a corner, the pipe itself is not going to change in length, okay? But the amount of space available to you in turning the corner is going to change. Okay? And so the idea here is that we want to represent how much space we have, which will be these two pieces. Let's say I call them A and B. Then the amount of space that we have is going to be A plus B. Okay? And we can generate different values for A and B based on the value of the angle theta. Okay? So theta here can range from 90 degrees if it's straight like this, and then it'll gradually get smaller and smaller and smaller until this will be 0 degrees. Okay? Mathematically, at 0 and 90 degrees, you'll have theoretically infinite lengths. That won't really be true, but the other lengths will be useful. Okay? Useful information. Let's see here. So I would use sine and cosine ratios to represent the lengths of A and B, and then add them together to generate how much space is available in the turn. Okay? So that's part A. In part B, then we want to graph this. All right? So I've got a separate video that talks about using the graph software. You can also use Desmos software if you're familiar with that. If you have a Mac, Mac has an excellent graphing calculator. If you search search for the grapher in your Finder on a Mac, you'll pull up an excellent graphing calculator. But if you want to use something else, please check with me, because some of them are really not appropriate. So those are the three that I think work very well. And like I said, if you want to use something else, then please check with me. All right. So we want to, then in part C, we want to find the minimum value on the graph. Now this is something that we did in Math 116, and in Math 111, we do root finding, which is similar. The process for finding a minimum point on a graph on that graphing calculator is you go into the calculate menu, which is second trace. Okay. Second button. Well, maybe I'll I'll show you in just a minute how to go about doing this. Second trace, and then let's see what choice is it after second trace. Choice number 3 is find the minimum, and choice number 4 is find the maximum, which I think, yeah, we're going to do in problem 2. Okay, all right, so let's see here. So that's part C, and then part D talks about why is that minimum value the maximum length for a pipe that can be carried around that corner. It's kind of a confusing question, but I do expect people to be able to answer it. All right, let's look at problem 2, and then I'll talk about using those minimum and maximum features on the calculator. So, problem 2, we've got this rain gutter that's going to be created by taking a sheet of metal and folding up the sides. Let's see, this one, not really very good. Get that drawn. So here's essentially what this gutter is looking like, okay? So you've got these 3 pieces. It starts out 30 centimeters, and then it's folded up in perfect thirds so that each of these is 10 centimeters. My drawing is not accurate. Let me make a better drawing because those angles should both be congruent, as well as these sides. Well, good enough. Okay. So we know that this is 10, this is 10, the middle's 10. We're going to have triangles on the sides there and there, and these are our angles. Theta is here and here. Like I said, those 2 angles are going to be congruent. Okay. Find an expression for the cross-sectional area of the gutter in terms of theta. So the cross-sectional area is going to be for this trapezoid right here, right? The area of a trapezoid is, and you can look this up as well, it's going to be 1/2 the height plus the sum of the 2 bases, okay? This base is going to stay 10, this base is going to be some function of theta, okay? As well as the height. The height is also going to be some function of theta. One of the bases is going to be 10, the other is going to involve theta. Okay? And it'll involve sines and cosines of theta, and then you can put them all together and generate an expression for this area in terms of the angle theta, and then we're going to look for a maximum value. Okay. And because the maximum value will produce the maximum area, which in 3 dimensions means a gutter that will hold the most water, or be able to shunt off the most water. All right, so before we wrap this up, let me just graph something here and then find a minimum or maximum for it. Let's see here. Let's do, what are we going to do? Negative x minus 4 squared plus 2. Let's see what that looks like. Okay, so there's the graph. If we want to find that maximum point, right, which is right up here, there's that maximum point. There's the second, and then trace is right here, second trace. Choice number 4 is the maximum. So hit 4. Now it's going to ask you for a left bound. Let's see here. Where is the cursor? Oh, the cursor's off the screen. It's down here where x is negative 0.3, y is negative 16. So I need to arrow to the right. There it is. And then I'll set a left bound to the left of the maximum value. Here is fine, here is fine, here is fine. Any of those points are okay. Hit enter, and now it wants a right bound. So we got to go to the right of the maximum value. There we are, that's good, this is good, this is a good point. They're all good points as long as they're to the right of that maximum value. Bypass the guess by hitting enter one more time. And there's your maximum value where x is, now this is something to know about these calculators. It says x is 3.9999979. That's 4. X is 4, okay? That's where that maximum value is, and y is 2. All right, so that's how we use the graphing calculator to find the maximum value. Finding the minimum value is very similar, except that you choose number 3 instead of number 4. Okay, like I said, there is a separate video for how to download and use the graph software, which I think is a great piece of free software. And so if you're interested in that, I'll post a video for that as well. If you have any questions as you're working through this, please let me know. These problems are not that bad, but I understand if you haven't done anything like them before, it's easy to get stuck. And then also the write-up is also a very important part of doing these projects. So if you get stuck, if you have questions, please let me know. Thanks.